Hello everyone, this is Shankar. I did masters from IIT Kanpur and faculty for Power Electronics at Home Institute, Hyderabad. In this video, I would like to discuss Power Electronics previous year questions from GATE 2010 and 2018. In those 2 years, the organizing institute is IIT Guwahati. Now let us go into the questions. First, I would like to discuss 1 mark questions given from these PYQs. Now the first question is, the figure shows a composite switch consisting of a power transistor, that is BJT, in series with a diode. Assume that the transistor switch and the diode are ideal. So what are the IV characteristics of this composite switch? Of course it is not mentioned, it is basically steady state conditions. Now suppose if you draw for BJT, let me draw here, for BJT, the steady state operating characteristics will be, as a switch, BJT can block voltage of positive voltage, positive polarity. That means when the BJT is in the turn off condition, it can block, as a switch it can block positive voltage, and when it is suitably given a base current, in the saturation region it will carry the positive current. Therefore, BJT will have unipolar and unidirectional feature. Similarly, for a diode, the steady state operating characteristics will be, during turn off conditions, diode can block positive negative voltage, and when the diode is forward biased, and it will carry the current in the positive direction, that is from anode to cathode. Now by combining these two devices in series, the composite switch will block positive voltage from which is contributed by BJT and negative voltage which is contributed by diode, and the direction of the current is always from, suppose if you take these two terminals A and B, the direction of the current is always from A to B. Therefore, this series combination of BJT and diode will give you bipolar feature during turn off condition or blocking state, and the current will be of unidirectional feature. Therefore, option C will be the correct answer for the question. Now let us go into the next question, that is, now here 4 power semiconductor devices are shown in the figure along with their relevant terminals. Now, what are the devices that can carry DC current continuously in the direction shown when gated appropriately? Now that means, now if you observe closely here, the current direction is given. Now say from here, this is a cathode terminal. Now here the current direction is given from cathode to anode for GTO. That is not the case, because GTO and thyristors, both the devices will carry the current from anode to cathode, and the given MOSFET here is N-channel MOSFET. N-channel MOSFET by default it will carry the current from drain to source terminals. Therefore, this is also not an appropriate option. But whereas triac is having a capability of carrying current in both the directions, therefore of course it is only one direction is given. So with this, appropriate options could be triac only. Okay, the given direction of current will flow from MT2 to MT1 in case of triac. That is the correct option. Even in this problem, if it is MT1 to MT2 is given, also triac is correct. Okay, because triac is a bidirectional switch. Or we can also have another question is, triac is equivalent of 2 SCRs in anti-parallel. Triac is equivalent of 2 SCRs in anti-parallel or 2 thyristors in back-to-back connection. So this question was given in GATE 2018 as 1 mark question. Now only these are the 2 questions from 2010 and 2018 from 1 mark questions. Now let us look into 2 marks questions. Now this is a very simple question. Let us look into carefully. The fully controlled thyristor converter in the figure is fed from single phase source. When the firing angle is 0 degree, the DC output voltage of the converter is 300 volt. What will be the output voltage of firing angle? 60 degree, assuming continuous conduction. Now in case of continuous conduction here, in continuous conduction, average output voltage expression will be 2 Vm by pi cos alpha, right? Now, when alpha is equal to 0 degree, what is V naught? That is 2 Vm by pi. This value is given as 300 volt. This value is given as 300 volt. Now, if alpha is equal to 60 degree, what could be this V naught? This V naught will be 2 Vm by pi into cos alpha, where 2 Vm by pi is given as 300. Now alpha is 60 degree means cos 60 will be 1 by 2. Therefore, this will be 150 volt, right? So this is a V naught is equal to 150 volt. That will be the correct answer. So option A will be the correct answer for the question. So this is MCQ for 2 marks. In this question was given in GATE 2010. Okay, I hope it is clear. Now let us move to the next question. This is also very simple and a conceptual question. A single phase fully controlled rectifier is supplying a load with an anti-parallel diode as shown in the figure. All switches and diodes are ideal. Which one of the following is true for instantaneous load voltage and current? Now, if you see here, this circuit is a single phase fully controlled rectifier with anti-parallel diode, okay, across the load. Therefore, for this particular circuit, average output voltage will be given by Vm by pi into 1 plus cos alpha, okay, 1 plus cos alpha. So because of this 1 plus cos alpha, we can say that average output voltage is always positive for any firing angle, okay. Suppose if freewheeling diode is not there, then alpha will be positive for, V naught will be positive for alpha less than 90 degree and V naught will be negative for alpha greater than 90 degree. That is a normal full converter operation. But the moment when freewheeling diode is connected, this output voltage will never go in the negative side. Therefore, V naught is always positive for any firing angle. Next, due to unidirectional feature of SCRs and diodes, output current is also positive, okay. Output current is also positive, okay. Not only average quantities, even instantaneous values also positive, okay. Therefore, option C will be the correct answer. V naught is positive and I naught is also positive. The same question we can also expect in a quadrant diagram, something like this. This is a V naught and this is a I naught. In this case, this particular circuit will give you only first quadrant of operation. Again, the same question if I extend, suppose if I consider the load as a DC motor, only this circuit can provide forward motoring operation only. Forward motoring operation only. We can have a question in any way. Again, we can also expect a question something like, suppose in the next time this FD is removed, for example. If FD is removed, in that case what will be the case? In that case, alpha less than 90 degree V naught will be positive, alpha greater than 90 degree V naught will be negative. So V naught can be either positive or negative, depends on the firing angle, but for any firing angle, average current or output current is always positive, okay. In that case, you will get first and fourth quadrants of operation, okay. That also we can expect. Next, this is a question, okay, let us go through it. The waveform of the current drawn by a semi-converter from a sinusoidal AC voltage source is shown in the figure. Now here I naught value is given, that means this specific, let me take a notation here, this magnitude is given as I naught, which is a 20 ampere, okay. So basically the given current waveform is quasi-square waveform. What is the RMS value of fundamental component of the current? Now for example, if I write Fourier series equation for this source current, it will be like this: sigma odd number of n, like sigma n is equal to 1, 3, 5 and so on, 4 I naught divided by n pi into cos of n alpha by 2 multiplied with sine of n into omega t minus alpha by 2. Okay, so this is a Fourier series equation for quasi-square function. Generally I used to derive this equation in the regular classes of GATE power electronics lectures. Now what is the question here? RMS value of the fundamental component. So basically what I can write, RMS value of fundamental component is equal to peak value of the fundamental divided by root 2. What is the peak value of the fundamental? 4 I naught divided by, now substitute n is equal to 1 multiplied with cos of alpha by 2, where n is equal to 1. This total value divided by root 2. Okay, divided by root 2. So this will be further simplified as 2 root 2 by pi into I naught into cos alpha by 2. Now let us substitute the numericals. 2 root 2 by pi numerical value is 0.9. I naught value is given as 20 ampere and alpha value is given as 30. Therefore, this will be cos 15 degree. So if you calculate this, you will get 17.38 ampere. Okay, 17.38 ampere. That is the answer. Now let us go to the next question. So this is a very straightforward question. It's just a memory based question. Guys, if you observe the pattern of the question, some problems, some questions will be memory based, some questions will be substitute formulas and some questions will be analysis oriented. For GATE exam preparation, you should have this mindset. Okay. Now let us read the question. The power electronic converter shown in the figure has a single pole double throw switch. The pole P of the switch is connected alternately to throws A and B. The converter shown in the figure is. Now here there are three varieties of connecting this particular thing. Now for example, case 1 is there is a source voltage VDC, and here if we connect the single pole double throw switch, this is one possibility. Okay, and second case is, of course, the second and third cases are not required for the question, but who knows, if you get specific to this question in the upcoming GATE exam, you will have some advantage after watching this video. Okay, so this is a second possibility, and the third case could be like this. Right, now in this first case, this topology is named as buck converter or step down, and this topology is called boost, and this topology is called buck boost. Right, now based on these three, the given circuit is step down chopper or buck converter. So very simple. So I will suggest you to practice the remaining topologies as well, which will be useful for the upcoming exam. I hope it is clear. Now let us move to the next question. Next, a phase. Now this is not a formula based question, and even the topology is also not a standard topology. This type of question we can consider a little bit analysis oriented. Now let us look into this question. A phase controlled single phase rectifier supplied by an AC source feeds power to an RLE load as shown in the figure. The rectifier output voltage has an average value is given by Vm by 2 pi into 3 plus cos alpha, where Vm is given, that is 80 into pi in volt, and alpha is the firing angle. If the power delivered to lossless battery is 1600 watt, then what is the alpha value? Okay, now here suppose power delivered to lossless battery, what does it mean? It means E into I naught. Of course, in this case, why I am telling it is analysis oriented, there is no information is mentioned about the nature of the output current, but with the way the question is framed, from that I can understand the load current is continuous load current or approximately constant, otherwise you cannot solve this problem. Okay, so this value is given as 1600, therefore I naught is equal to 1600 divided by, now see here, the battery voltage is given as 80, therefore I naught value is equal to 20 ampere. That is what we calculated, right? Next, this I naught value we can equate it with the average output voltage. We can use it, right? What is average output voltage from here? R into I naught plus average inductor voltage will be 0 plus E. Okay, therefore 2 into 20 plus 80, right? This value will be 40 plus 80, 120 volt. Now this 120 volt should be equated with given expression. Now what is that? Vm divided by 2 pi into 3 plus cos alpha is equal to 120. Okay, so but what is Vm given? 80 into pi divided by 2 pi into 3 plus cos alpha is equal to 120, right? So left side it will be 4 times, it will cancel here, therefore 3 plus cos alpha is equal to 120 divided by 4, it will give you 3. So 3 can be cancelled on both sides, therefore we will have cos alpha is equal to 0, that means alpha is equal to 90 degree. So 90 degree will be the answer for the question. Okay, we want alpha value in degree, that will be 90 degree. I hope it is simple. See, gate questions are not so much complicated questions, but you need to apply little bit analysis part. Okay, next one. Now this is also analysis oriented question. Now earlier at the time of 2010 there is a questions called linked answer questions and common data questions. Of course these questions have been removed nowadays. Instead of common data and linked answer questions, now new questions introduced, that is called multiple select questions. Anyhow, just as a conceptual understanding, you can consider this as a 2 MCQs. Now let us look into the question here. The LC circuit shown in the figure has an inductance of 1 millihenry and a capacitance of 10 microfarad. The initial current through the inductor is 0, while the initial capacitor voltage is 100 volt. If the switch is closed at t is equal to 0, what is the expression for current through the circuit? Now, if you observe carefully here, for this circuit, there is no sourcing function, like there is no voltage source given here. But whatever initial voltage across the capacitor, that itself acts as a source for this circuit. Therefore, based on that, what I can write down, at when the switch is closed, when switch is closed at t is equal to 0, you can write down this current equation. Let me call it IC. This equation will be given by Vc naught, which is initial voltage across the capacitor, into under root C by L multiplied with the sine of omega t. I am not going into the derivation. I hope If you are a gate aspirant, you can easily solve this equation. I will tell you the procedure. When the switch is closed, first you have to write down a KVL. What is KVL? L into di by dt plus 1 by C integration I dt is equal to that source voltage, right? Now, if you apply Laplace transform and solve it, you will get an expression here. Now, in this case, what is omega? Where omega is equal to 1 by root of LC. Now, if you substitute the numericals, inductance value is given as 1 millihenry, therefore 10 power minus 3. Capacitance value is given as 10 microfarad, that means 10 power minus 5. Therefore, it will come in the numerator 10 power 8 under root. So, it will be 10 power 4 radian per second, because this is a omega. Okay. Alright, that is omega value. Next, Vc naught into root of C by L, where Vc naught, initial capacitor voltage is given 100, and into root of C by L, where C is a 10 power minus 5 and inductance value is 10 power minus 3. This value you will get 10 ampere. Therefore, expression for capacitor current, that means IC, is equal to 10 sine of 10 power 4 t in ampere. Okay, sine of 10 power 4 t in ampere. So, which option is matching here? Option D is matching. Okay, 10 into 10 sine of 10 power 4 t in ampere. So, this is the question. Now, linked answer question means, now you got this equation, this data will be useful, this particular answer will be useful as a data point for the next question. That is what linked answer question. Earlier gate questions were like that. Now, the LC circuit in the previous question, that is question 8, is used to commutate a thyristor which is initially carrying a current 5 ampere as shown in the figure below. The values and initial conditions of L and C are the same as in question number 8. The switch is closed at t is equal to 0. If the forward drop is negligible, what is the time taken for the device to turn off? Now, for example, here, before switch is closed, what could be current flowing through SCR? Let me call it as IA, anode current, that is 100 volt divided by 20 ohm, that will give you 5 ampere, right? Next, suppose if the switch is closed, if switch is closed at t is equal to 0, if switch is closed at t is equal to 0, in this case we cannot say that anode current is simply equal to 5 ampere, because at this instant, let us say this is I naught, this is anode current, and capacitor current is IC. Okay, therefore, if you apply KCL, you will have IA plus IC is equal to I naught, right? Now, this IC is given by previous question, this equation 10 into sine of 10 power 4 t. Now, here we need to find out how much time the device will take to turn off. So, device will turn off, device means here SCR, device can turn off when IA is equal to 0. If IA is equal to 0, what will be this equation? IC is equal to I naught, where I naught is equal to 5 ampere. But what is IC here? 10 sine of 10 power 4 t, this is equal to 5 ampere. Okay, therefore 10 power 4 t is equal to sine inverse 5 by 10. Okay, sine inverse pi by 10 means pi by 6. Therefore, t is equal to pi by 6 into 10 power 4. This will give you 52 microsecond. Okay, t is equal to 52 microsecond. So, option A is the correct answer. T is equal to 52 microseconds. So that means here the main important concept, this is based on the commutation circuit, right? Suppose if this LC circuit is not connected, in other words, if the switch is not closed, once the SCR is turned on, when it is a DC circuit, always 5 ampere will flow. That means one of the condition for SCR to commutate, that is the anode current should be less than holding current, that condition will not satisfy. In order to create or in order to turn off the device, we took the help of LC circuit from the previous question. Now, when we connect that previous LC circuit here, the moment when the switch is closed, KCL equation will be given by IA plus IC is equal to I naught. Okay. So now the question is, find the time for the device to turn off. When device will turn off? Whenever IA is equal to 0. If you make IA is equal to 0, that will be IC is equal to I naught. By equating this equation, you will get T is equal to 52 microseconds. So the concept is, once the device is turned on, once the switch is closed, then from that instant, after 52 microsecond, SCR will get a commutate or SCR will get a turn off. It's a very nice question from 2010 paper, right? Next. Now this is another interesting question. By seeing the circuit diagram in 2018, most of the students got panic. It's a very simple. The only thing is you need to maintain that peace of mind in the exam hall. The figure shown, two buck converters connected in parallel. Okay, this is a one buck converter here, another buck converter. Both are connected in parallel. Parallel means what? Immediately output voltage for the two buck converters will be same. Okay, that is the first observation. Next, the common input DC voltage for the two converters has a value of 100 volt. That means for both the converters, input voltage is common. The load resistance is 1 ohm. One more point I missed, sorry. The converters have inductors of identical value. That means these two inductors have identical value. Why? Just to share the load current equally. Okay. Next, the load resistance is 1 ohm. Okay. The capacitor voltage has negligible ripple. What do you mean by that? Capacitor is large and in such a way that voltage across capacitor has a negligible ripple. That means output voltage of capacitor is almost constant. Both converters operate in the continuous mode. The switching frequency is 1 kilohertz, that means 1 millisecond, and the switch control signals are shown in this figure. So based on these two control signals, immediate observation is duty cycle ratio is equal to 1 by 2 or 0.5 by 1, that is a 1 by 2. The circuit operates in steady state. Assuming that the converters share the load equally, the average value of I switch 1. So here S1 indicates a switch. So this is I switch 1. So let me use a switch, otherwise it will confuse with the source current. The current of switch S1 in ampere. So final question, what is the question here? You should find what is the average value of S1 current, switch 1 current is. Okay. So let us try to find out. First we will have a few calculations. What is that? First let us find what is V0. V0 is equal to let me find here. For buck converter, V0 is equal to D into VDC. 1 by 2 into 100. This will give you 50 volts. Okay. Then what is average output current? That is V0 by R. So that will give you 50 ampere. Therefore, average load current will be 50 ampere. Okay. I hope it is clear. This is I0. Next, because the two inductances are identical, I can say that, again one more thing, in steady state the average current drawn by capacitor will be 0. Therefore, what will be current drawn by these two inductors? They will share equally. It will carry 25, it will carry 25. So average inductor current drawn by the two circuits will be 25 and 25. Now, with this, if you draw switch current waveform, switch 1 current, switch 1 will carry inductor current when it is on, right? That is, let us take x-axis in millisecond, that is 0.5 duration, and 0.5 to 1 millisecond, the switch 1 current will be 0. Now, when the switch 1 is turned on, how much current it will carry? That will be inductor current, that will be 25 ampere. Now, from this waveform, what is the question here? What is average value of the switch current? That is 25 into 0.5 will be area, denominator 1, that is a full cycle time. So, this will give you 12.5 ampere, okay. This will give you 12.5 ampere. So, average value of the switch current will be 12.5 ampere. This is the answer. 12.5 ampere. So, circuit looks very little bit scary, and a lot of information is also given. Because of this type of conceptual questions, sometimes students will get panic in the exam hall. So, I will suggest, if you just maintain that peace of mind, you can easily solve it. Otherwise, you can just postpone this question till the end of the exam. But if you struggle these type of questions in the very beginning, lot of time, it will take lot of time. So, this type of lengthy questions, you just push it to the end of the question paper, but they're easy only, not so difficult. Only thing is, understand the question statement and apply the concept. Now, in the same exam, again GATE 2018, from DC to DC converters, one more conceptual question is given. Let us look into that. A DC to DC converter shown in the figure is charging a battery bank B2, whose voltage is constant at 150 volt. B1 is another battery bank whose voltage is constant at 50 volt. The value of inductor is 5 millihenry, and the ideal switch S is operated with a switching frequency of 5 kilohertz with a duty ratio of 0.4. Once the circuit has attained a steady state, and assuming the diode to be ideal, how much power is transferred from B1 to B2? So, first let us write down few basic equations. Now, in this case, switching frequency is given 5 kilohertz. Therefore, what is the cycle time? Let me calculate. 1 by 5000, 200 microsecond. Okay, this is the first thing. 200 microsecond. Just keep it like that. Now, when switch is on, by the way, what is this circuit here? This circuit is a boost converter. Right. Now, when the switch is on, L into dIL by dt is equal to how much it is? 50 volt. In other words, when the switch is turned on, slope of inductor current will be 50 by L. Next, when switch is off, in that case, L into dIL by dt is equal to minus when the switch is turned off, then the inductor current will freewheels through diode like this. In that case, the voltage will be 50 minus 150. Okay, let me write like that. 50 minus 150. Therefore, dIL by dt is equal to minus 100 by L. Okay, minus 100 by L, right? This is the slope of inductor current when the switch is turned off. Now, we need to find out how much power transferred from B1 to B2. That means power transferred from B1 to B2 is, let us say P1 is equal to voltage across battery 1, that is V1, let me call it V1, multiplied with average inductor current. So, from this particular concept, what you have to calculate, that is average value of inductor current. Okay. So, if you draw the waveform for this inductor current, when the switch is turned on, that means dt will be d is given 0.4, therefore this will be, let me write dt itself, dt inductor current will increase with a slope of 50 by L. Okay. Next, from dt to t, now if you observe carefully here, the storage of energy in inductor is taking place for a period of 80 microsecond. Okay. Suppose if I take this time period microsecond, this value will be 80 and this will be 200. Am I right? Now 80 microsecond, the inductor current is increasing with a slope of 50 by L. Now in the remaining time period, what is the remaining time period? That is 80 to 200 means 120 microsecond. In that period, the inductor current slope is double. Okay. Therefore, this current will come to 0 definitely before the cycle time. The current will come to 0 definitely before the cycle time. Okay. So that means this current will be reaching to 0, let us call it at a beta t. And in this period, what is the slope of this line? Minus 100 by L, right? So this is a inductor current waveform. So in this waveform, let me call that is a IL peak. Again, the same waveform will repeat periodically in the next cycle as well. This is how the periodic waveform for inductor current. Now, from this waveform, you need to calculate two data points. One is peak value of the inductor current, another is this beta t. So, this particular waveform is clearly telling you that inductor current is having discontinuous conduction mode. DCM operation means discontinuous conduction mode. In discontinuous conduction mode, in DCM operation, boost converter output voltage can be expressed like this: VDC multiplied with beta t divided by beta t minus dt. Okay. So what is V naught here? That is 150. VDC is a 50. Beta t by beta t minus dt, where dt is equal to 80 microsecond. Now by solving this equation, we will get beta t is equal to 120 microsecond. We will get beta t is equal to 120 microsecond. Okay. So this beta t value will be 120 microsecond. X axis I am plotting in a microsecond scale. Next, we would like to find out what is the peak value of this current waveform. Suppose if I take this triangle XYZ, in triangle XYZ, slope 50 by L is equal to opposite side YZ divided by adjacent side xz. Therefore, yz, which is 50 by L into xz. Okay. Therefore, what is yz? Peak value of inductor current. 50 divided by inductance value is given as 5 millihenry. 5 into 10 power minus 3. Xz value is 80 microsecond. 80 microsecond. So from this, the peak value of inductor current, we will get, if you calculate this value, IL peak is equal to 0.8 ampere. Okay, 0.8 ampere. Okay, now we got peak value of inductor current. Next, what else? IL average. We need average value of inductor current. Average value of inductor current means area of the triangle half into height into base dt, denominator t. So this will give you 1 by 2 into 0.8. Now here t cancel into 0.4. Okay, into 0.4. I'm sorry, this will be, you have to take a beta t here. Base of the triangle is beta t, right? Beta t, I'm sorry, and the denominator t. So what is beta t? Beta t will be 120 microsecond, denominator 200 microsecond. Okay, so with this you will get average inductor current is equal to 0.24 ampere. Average value of inductor current is equal to 0.24 ampere. So before starting this problem, you should have a mindset what is given and what is asking. It is given that there are two sources, in between there is an inductor and switch, that is a boost converter. You have to calculate how much power is transferring from one voltage source to another voltage source. For that, you need voltage is given already and you have to find average value of this inductor current. For that, we plotted an inductor current waveform. How to find average value? Area under the waveform divided by cycle time. To find area, you need height and this base. Beta t is calculated from this discontinuous conduction mode V0 equation. This height of the triangle is calculated simply by applying slope equation. Now you can find out what is P1. P1 is equal to V1 into IL average, where V1 is 50, this is a 0.24. Okay, so this will give you 12 watt. This will give you 12 watt. Okay, so this is the answer for the given question. Now in this paper, in this 2010 and 2018 gate papers, there was no questions from inverters chapter. Therefore, I am not going with that. These are the questions I collected from 2010 and 2018. So for the upcoming GATE 2026 exam, which is expected to conducting by IIT Guwahati, so earlier papers inverters questions were not given. That is one of the untapped area we can consider. Who knows, if they give, you can give, but completely you cannot ignore this chapter. Okay, this is important. But if you see the pattern of the questions are not so easy and not so difficult also. Only thing is, if you understand the concept and if you apply the base little bit analysis, most of the questions are analysis oriented only, especially from power electronics. Okay, so with this I wish you all the best. I will close this video. Thank you.